Okay, so we're doing word problems, linear equations. We're going to be looking at slopes, y-intercepts, plugging in for your x and y equals mx plus b to solve for y, or maybe plugging in for y and solving for x. In this case here, we have your cost of call, your y. And if you're working with slope, that's going to be your y2 minus y1 there. This being our y2 and this being our y1. Here's my x1, x2. So I could plug in 14 minus 7. And if we're solving for this, what I want to do is 7.07 minus 3.57 and get 3.5 over 7. And then we could reduce that and say, okay, 3.5 divided by 7 is 0.5. So actually my slope here is going to be 0.5, and that helps me eliminate choices A, and C here. Now if I want to plug in this slope and get one of these values, what I would have to do is say, okay, is it 0.5 times 7 minutes plus $7? If that's the case, if I plug in 7 for x, I should get 3.57. Or is it 0.5 times 7 plus 0.07? Now if I'm using my calculator here, I could say 0.5 parentheses even plus 7 and get 10.5. That's my result here. And then if I'm doing 0.5 times 7 plus 0.07, here I have the 3.57. So once I plugged in my value for x and using the correct equation with the correct slope, that's how I'm able to identify, okay, this is my correct equation because it's giving me a result of 3.57. A longer way of doing it would be plugging into this equation here, but I believe this is the best way, just finding your slope, plugging in, and seeing which results, especially if they're giving you multiple choice. If they don't give you multiple choice, and you're saying, okay, you would have to actually plug in y minus your y1, 3.57, equal to 0.5 x minus 7 here. You would actually have to plug this in and get it to be y equals mx plus b. Let's look at the second problem here. Cost of a school banquet, $75 plus $14 for each person. I want to be able to identify this as, for each person, per person. That's going to be my slope. Okay, and here, something that's a cost up front, like a membership fee, enrollment fee, this is going to be my y-intercept. Because with zero people, it's still going to cost me $75. So I'm going to want my equation to be 14x plus 75. Now they're asking what is the cost for 96 people. X is your value for people. Y is your cost, total cost. So here I'm going to do y is equal to 14 times 96 plus 75. 14 parentheses 96 plus 75. Result in 1419, which is my answer choice A here. Next question. Here we're talking about average price of a home in 1980. So in 1980 it was $98,000. I think making a list here is important. It helps you take the information out. In 87 it was $112,000. Which of the following is a linear model for the price of the home P in Brainerd County in terms of, so first thing I want to do is, okay, 7 years have gone by, so let's look at, okay, I have 112,000. This is my Y2. I could call this my Y1, the cost, minus 98,000, over change in years, which would be 87 minus 80. So we get 112 minus 98, which gives me 14,000 over the 17 years, which is basically $2,000 for every 1 year. And that helps me find my slope, which in this case would be here. This is a negative slope, so that's not going to work. This is for every 7 years, so that doesn't work. This is a negative slope, that does not work. So this is my correct answer here. And again, if I wanted to know a certain year, let's say the year 2000, I could just say, okay, 2000 times the 20 years plus the 98, which it was in its original year, which is what it was at 0 years. If t is equal to 0, that means this is 0 years and this is 7 years here. Next problem. This is basically what we're looking here, change in year that goes 10 years, 10 years. You could get this straight from your table, 10 years. And then here you have an increase of 80, 80, 80, 80. So actually, if population is changing, and let's make population my y, because that's the total amount, and then make the years x, because that's my change, that's what's changing basically is the time. This is my time, or years. Okay, and they're looking, what will the population be in 2018? Well, I know for every 10 years, it's changing. This is in is this in millions? Well, let's say it's changing about 80 people, and then for every 10 years, which means it's changing 8 people per year. Okay. Now, in the original year, it starts at 80. So at year 0, you have 80. So let's say it's your equation is going to be y is equal to 8x plus 80. Because in year 0, you have a population 80, and it's going to go up 8 each year. So if I want to find out 2018, I would do 2018 minus 1960, and I get about 58 years there. So I could say y is equal to 8 times 58 plus 80. Is about 544 people. Again, one of the skills I have here is that recognizing usually year and time, that's going to be your x. That's going to be, you know, basically what's going to help you find your slope. And then your population, that's usually going to be your y. And what I'm doing is I'm finding a change in y over a change in x. I'm doing, okay, 160 minus the 80, and I'm doing 1970 minus 1960. Here's my population, and here's my years. That's my y. This is my y2 minus y1 here. Last problem. This is a candle problem here. I like this one, and I like how they present this. Basically, because the idea here is it's a little bit different. You're starting, I think a good picture here is good. You're starting at 5 inches tall, and which means on a graph, you're starting here at 5. Now, if the candle's burning, it's going down, and basically what they want to know, it's going down by 2.5 inches per hour, so it's going to go in some negative slope fashion. Now it's starting at 5, so at 0 time, it's at 5. That's going to be your y-intercept. And then it's going down. It's burning. So the slope is going to be negative here. Now, if you wanted to know you know, when will the candle burn down? Well, you could say, okay, that would be 0 inches. That's when the candle's at 0 inches. So if I solve for x, basically solving for the time, okay, and you know, I have -5 over 2.5, so basically the candle's going to burn down after 2 hours. So if I were to put that on the graph, here would be my 2 hours, and at 1 hour, it's about 2.5. So I'd be able to graph that here and be able to do all things.